Hey everyone, welcome back to day 8 of our Python Master course. In the last lesson, we explored lists, how to create them, modify them, and use them in loops. Today, we move on to tuples and sets, two more essential data types of Python. Let's jump right in. A tuple in Python is just like a list, but with one major difference. Tuples are immutable, meaning once created, they cannot be changed. You create a tuple using parentheses, just like this. My underscore tuple, then the is equal to parentheses, and then let's say 10 comma 20 comma 30 inside it. Press enter. Now if you try to change value, Python will give you an error. So why does Python even have tuples? Because immutability has advantages. They are faster than lists, they're safer because their values cannot be altered. When you work on really long Python codes, which are like about 1,000, 2,000 lines, then there is always a risk of accidentally changing your list, or altering it in one of the lines, and then you don't really want that alter in your entire code, and it becomes difficult to debug it, to go back to the first part and then debug it, and like it becomes difficult. So that's why tuples are more helpful in such situations. But when you really want a list to be altered or anything to be altered, then lists are the best thing. And they can also be used as dictionary keys. We'll be learning about that soon enough. Even though tuples cannot be changed, you can still access elements, slice them, count and index them, concate them, convert between list and tuple. All of them are very important, out of which access elements and slicing is something what we had learned about in lists as well. So I won't be telling in detail about that, but I'll just give you a brief overview by just showing it. Print my underscore tuple, square brackets, and then over here I'll give the zeroth index. Okay, the tuple spelling over here is wrong. Excellent. After that, print an empty line. After that, print parenthesis my underscore tuple. Then after that, I'll give square brackets and first index to the last index. Excellent. Now I'll again give one blank line, print. Now, over here is the part where we study about the count and index part, which we have not learned in the list. So we put the print function, the parenthesis, print, and then the parenthesis my underscore tuple. After that, we put dot count, then the square brackets, and then next we put print my underscore tuple dot index. Then let's give another value of 20. Excellent. So before I run the program, I just wanted to share one information about Google Colab. That Google Colab is an online a code editor used only for Python. So you can use Google Colab as a basic tool. It's really helpful for those who are really beginning to learn Python. Um, and this is really useful because most of the simple libraries are already installed onto Google Colab, so all you have to do is import them. But once you get a little bit more advanced, then you have to install them either which ways, and that's where VS Code comes to help. You can easily do it, and also VS Code can be used for multiple other languages, like almost all of them. And all the coders and programmers worldwide prefer to use VS Code over online tools because VS Code can also work offline generally, unless you want to install something, and in certain cases, of course, it does not work. But mostly it can work offline. So that's why um, VS Code is a better choice. But today, my VS Code is a little bit busy with some other work on some other project which I'm working on. That's that I'm using Google Grab. Excellent. Now let's run the file. It will take some time for you to run the file at the start because, well, it's online server, so it has to connect with Python 3, and then, well, it takes some time. Okay, there is a type error in line number. Where is it? Line number 6. So 1, 2, 3, 4, 5, and 6. Okay, my tuple. Okay, in cell 0. Bulletin function, or okay, some Okay. Well, the error is that it's actually not square brackets, it's parentheses. My apologies for that confusion. Square, same over here. Sincerest apologies on that part. Now it shall run perfectly. Excellent. So now, as you can see, the first one, which is the my tuple underscore zero. So, well, now that prints the first like 10 because that's the zeroth index. Then the next one prints all numbers from the first index, which is 20 and 30, and the print my tuple dot count 10. Now it prints one. Well, that's the count of the tuple, like where this is situated, and it prints the first index, like it prints one for the next one of a dot index because, well, 20 is on the first index. Now let's just change the value slightly, 20, and let's keep it 30 so that you get the difference between them. Exactly. Now it still prints one. Basically, why does it print one? Because it's the count, and index value, of course, changes to 2. Now I just leave one line, print. So basically, let me just explain this in like simple terms. It just checks how many times is 20 there in the list. So now if I put 22, see, this is the use of the count feature. So when you're working on thousands of lines of codes or in hundreds, then this is a useful tool. Next, we move on to concatenate a new. Okay, so let's say we have to assign a tuple into a new tuple. This is useful when you don't want to really change or like um, work on the original tuple and still save the original tuple. This is when you use it. New underscore tuple is equal to my underscore tuple plus 40 comma 50, and you put the parentheses over 40 and 50 like this. So we print new tuple, print new underscore tuple. Exactly. So it prints 10, 20, 30, 20, 10, 20, 30, 20, 40, 50. So as you can see, we have printed 10, 20, 30, 10, 20, 30, 20 on my underscore tuple. But in new tuple, 40 and 50 is added. So like how I explained, if you don't want to really edit the original tuple and want to retain its value, then you can assign the tuple like this. This is really useful when you're working with user interfaces and backend and all. Now, the next part, which is convert list and tuple. So, now you can convert a list into a tuple and a tuple into a list. So, let's just do it list underscore version. Let's give an example of version is equal to list the parenthesis my underscore tuple. Excellent. Now, print list underscore tuple. Sorry, version. Let's run the code once again. 10, 20, 30, 20. So now it prints this what my tuple is now, but this became a list now. So list underscore version is basically that it converted the tuple into a list, but it's the list is only stored in the value of list underscore version. So the main original tuple, which is my underscore tuple, is still like that. So now you can edit the tuple. This is where the list happens. This conversion is useful if you want temporary mutability. So if you want to change temporarily, then it's useful. When should you use tuples? Use a tuple when your data should not change after creation. You want faster performance. You need to store fixed collection like coordinates, etc., etc. And tuples give stability to your data, which is really important. Now, let's move on to sets. Set is a collection of unique items, unrolled, mutable. You can add or remove elements, just like a list created using braces, or more commonly known as curly brackets, or the set, which is more commonly known as parentheses. example is let's say print my underscore set is equal to the curly brackets or the set or the braces is equal to 1 comma 2 comma 3 comma 4 comma 5 comma 6, and then now print my underscore set. Now this is how you print. Notice how duplicate items are going to be removed. Just please notice that part. 6. Exactly. So now 6 is removed because it's like duplicated once, because like it's there is one more of 6, that's why it's removed. So this is useful when you just want to check out any repeated data. So you can use set. Set operations. Sets shine when you need to perform mathematical style operations. You need to add items, remove items, and union. Combine all elements from both sets. Like if you have two different sets and you just want to combine them, and such as useful. Intersection, yeah, and symmetric difference. These three things are what we're going to learn in this Python master class. The remaining is similar and same, almost same to what we had learned in this. So I'm not going to go in detail into that. Firstly, we'll just print a line over there. Sorry, Control Z, print. Excellent. Now, let's say we want to combine all elements from two different sets. We have set A and set B, and we just want to combine the values of it. So let's give A is equal to the braces 1, comma 2, comma 3, and let's give B is equal to braces 4, comma 5, comma 6. Enter, and now we have to print both of them. We just put print the parenthesis like usual, A, then the standing line B. Exactly. Now you'll see the magic. See, now set A and set B both are printed together. So now it becomes 1, 2, 3, 4, and 5 and 6. This is the use of union. Say there are two sets of students, and at start, just to make work easy, you want to divide the paper correction into two different sets. Then you create two sets A and B, and then at the end you want to give the results. Then you just combine them back together. Next is intersection. Let's just use the same thing. Print bracket print A and B set. Exactly. So, elements in common elements. It just prints out all common elements. Currently, there's no common element. That's why I didn't print out anything. Let's just keep one common element. So three, let's say 3, comma 4, comma 5, 6. Exactly. So it prints out three over here. It printed set because there's no like common element. Now it printed three because three is repeated in both in A and B. So in case if you want to find any error, like in case there are two, like if one student's name is repeated in both of the sets, then you can check it out by using this. Next, we move on to the last part, which is symmetric difference. We'll again use the same example, print A, the this sign, and B. Sorry, apologies, I don't know what the sign is called. Yeah. So what it do? It removed the same, like see, three was repeated twice, right, in both A and B. So that's why it just removed three and it just printed 1, 2, 4, 5, and 6. This is the use of symmetric difference. Now, when to use sets, you need unique values only. Order does not matter. You want to perform membership tests or student tests, etc., etc. So now we'll just move to the last part of the video, which is lists versus tuples versus sets. So the feature. Lists are mutable, while tuples are not, and sets again they're mutable. Lists are ordered, tuples are ordered, and sets are not. Lists allow duplication, allow duplication, and sets do not allow duplication. Use case of list is changing data, tuple is fixed data, and set is unique items and operation. So the rule of thumb: use lists when you need flexibility, use tuples when you need data is constant, use sets when you need uniqueness or mathematical operations. And that wraps up for day 8 of our Python course. Today we learned about tuples, sets, and their operations and when to use which. If you're enjoying the series, make sure to like the video, comment your questions, subscribe for day 9, dictionaries,